The maintenance phase follows the induction phase. This phase begins after the patient has been rendered unconscious by an induction agent and intubated with an appropriately sized endotracheal tube. It is here that the patient can be maintained unconscious with the aid of an inhaled anesthetic delivered by an anesthetic machine. Before discussing the maintenance phase, let's take a minute to review the components and operation of the anesthetic machine. We'll begin with the oxygen source. A tank of medical-grade oxygen can either be attached to the anesthetic machine or stored elsewhere and piped into designated rooms in the hospital. A portable anesthetic machine will have an oxygen hose, green, that will snap into the plumbed oxygen line. The oxygen tank is generally turned off at night or when not in use, so it will need to be turned on prior to initiating anesthesia. A pressure gauge will indicate how full the tank is. When the oxygen pressure is at or above 2,000 pounds per square inch, the tank is considered full. When the oxygen drops below 400 to 500 pounds per square inch, it's time to switch tanks. The flow of oxygen to the patient is controlled by the oxygen flow meter and is generally measured in liters per minute. The flow is determined by the size of the animal and the type of breathing system used. Some anesthetic machines also use nitrous oxide for added analgesia and as a carrier gas for the inhaled anesthetics. Nitrous oxide helps to produce and maintain anesthesia by providing analgesia or pain relief. It must be remembered that when nitrous oxide is used in addition to the oxygen supplied to the patient, it should not be administered at greater than 70% of the total gas flow. The patient must always receive at least 30% oxygen. After the oxygen or oxygen and nitrous oxide pass through their respective flow meters, they're directed to the volatile anesthetic vaporizer. It's here that the inhaled anesthetic drug is mixed with oxygen. The oxygen, or oxygen nitrous oxide inhalant anesthetic gas combination, is then delivered to the breathing circuit and to the animal. Though various volatile drugs are used, the two most common are isoflurane and sevoflurane. These drugs start as liquids and are vaporized to produce the anesthetic vapor. Vaporizers are precise instruments designed to accurately vaporize specific types of volatile anesthetics. There's a large dial on top of the vaporizer that controls the amount of anesthetic delivered to the patient. The higher the percentage, the more anesthetic gas delivered, and the deeper or more unconscious the patient becomes. The vaporizer is the critical component of the anesthetic machine used to control the patient's level of consciousness or depth of anesthesia, and will need to be frequently checked throughout the anesthetic process. Most animals, when first placed on inhaled anesthetics, generally require a higher anesthetic concentration, but the vaporizer can then be adjusted to a lower setting once they're adequately anesthetized. The vaporizer will need to be periodically refilled when indicated in the small window shown here. Another component of the anesthetic machine is the breathing circuit. This system contains two one-way breathing valves, breathing tubes, a rebreathing bag, a pop-off valve, and carbon dioxide absorbing canister. We will discuss only the circle rebreathing system, but be aware that there are other types of breathing systems in use. As gas exits the vaporizer, it's mixed with a precise amount of vaporized anesthetic drug. The gas mixture passes through a one-way valve into the endotracheal tube and, during inspiration, into the patient's lungs. When the animal exhales, they breathe out gas and the waste product carbon dioxide. This carbon dioxide is removed by the carbon dioxide absorbent material, soda lime, in the canister. The CO2 absorbent granules are designed to turn blue when they are no longer effective for removing CO2. This is one indication that they'll need to be replaced with fresh granules. After the carbon dioxide is removed, the exhaled oxygen and gas enters a rebreathing bag. This bag will inflate and deflate with each breath, and therefore an appropriate sized bag should be chosen for each animal. A portion of the gas leaving the bag leaves the system entirely and passes into an exhaust tube called a scavenger system. This gas should be vented outside. The amount of gas leaving the anesthetic circuit is controlled by the pop-off valve. Fully opened, this allows the maximum amount of gas to escape into the scavenger system. Fully closed, no gas leaves the system, while new gas and oxygen are steadily being added. A fully closed pop-off valve can be dangerous to the pet and should not be fully closed except for very brief periods when the animal is being manually bagged or mechanically ventilated. By compressing the bag with the pop-off valve closed, the lungs can be inflated. This is sometimes beneficial when an animal is not breathing regularly on its own. This anesthetic circuit efficiently recirculates the anesthetic gases as well as the humidity beneficial to the respiratory system. Fresh oxygen can be added to the system by depressing the oxygen flush button. Remember, however, that pressing the oxygen flush button allows oxygen to enter the circuit without going through the vaporizer. This dilutes the concentration of anesthetic vapor in the anesthetic circuit, which could cause the animal to wake up. As mentioned earlier, non-rebreathing systems are commonly used on animals under 15 pounds. The primary difference between this system and a rebreathing system is the absence of one-way breathing valves and a carbon dioxide absorbing canister. The oxygen flow rates are generally greater in order to prevent the patient from rebreathing exhaled gas. Once the exhaled gases leave the patient, they are routed into the scavenger system and are not recirculated. The systems we have discussed rely on the animal to spontaneously and physically inhale and exhale in order to make the breathing system work. Mechanical ventilators assist the inhalation of oxygen and anesthetic gases by forcing the gases into the patient's airways. Ventilators are beneficial for the patient that is not breathing regularly or adequately. Once the animal has been given an induction agent and intubated, they're connected to the gas anesthetic machine, and the oxygen flow and vaporizer are adjusted to the animal's needs. The animal's anesthetic depth will now begin to be controlled by the gas from the vaporizer as the effect of the initial intravenous injection begins to wear off. The principal advantage of the inhaled anesthetic machine is that we are now able to control the depth of anesthesia for an extended period of time, even up to several hours, by adjusting the vaporizer setting. At the end of the procedure, the vaporizer is turned off, and within minutes, the patient begins to regain consciousness. It must be stressed at this time, however, that the delivery of too much anesthetic can be life-threatening, and careful monitoring is vital during anesthesia.